So I'm recording. Do you recognise this curve? So from yesterday, I'm hoping you'll go, I know that that one is sine. Okay. So should we write that one down? So this is y equals the sine of x. Okay. Now there are certain things that we are going to label on this graph, which is why I've given it to you with lots of space. All right, there's certain things that we need to know. So this, you go above 90, look, and go up to what's called the maximum. Okay, this distance here, if you label this distance here, is called the amplitude. All right, and in this case, the amplitude is 1. Okay, so with the sine curve, the amplitude is 1. That make sense?
Yeah.
Yeah. Could you generalize that for me? How does that resonate with you in your head? How could you explain what the amplitude means? Okay. Also, though, just to make you aware that this is also the amplitude. So it's actually this is also the amplitude. So actually what we could say is this is the minimum value down here, which in this case is -1. 1 up here is the maximum. So actually the best way of saying the amplitude is 1, it's the difference from max to min divided by 2. Does that make sense if I say that? So we look at what the maximum value is, we look at what the minimum value is, which is -1, and the difference there is 2. So we take that number and we divide it by 2. Now the reason why I say it like that is actually because it's not always just where the maximum is, so we've got to be careful. That make sense? Okay. So there's another thing that we need to talk about, which is called the wavelength, okay, also known as the period of the function, and in this case, it's 360 degrees. Now, does that make sense to you looking at that graph? Yeah? How would you identify the wavelength then? What would you say?
The difference is 2 because the max is 1.
Well, it's not actually got anything to do with the minimum and maximum. Pardon? Yeah. So a wavelength, remember yesterday I said this shape goes on forever, right? Now, if you look at the wavelength, if we start at the beginning and go all the way up to the maximum, back down to the minimum, and then we get back to, so we have got 0, it starts here and finishes here. How long did that take to happen? 360 degrees. Okay? So our wavelength, also better called the period of the function, is 360 degrees. Okay. So they're two important things that we need to be aware of and know what they're called. And we're going to, do you remember we looked at changing those coefficients to A, B, and C yesterday? Yeah? And we looked at, well, if I changed the A, B, or C, it changed the amplitude or the wavelength. Yeah? Okay. So the next curve on your worksheet is this one. And you've done well, you've recognised this one as y equals the cosine of x. Is there any way you can just state, this is how I know the difference between cosine and sine? What do you think? Well, do you remember yesterday, they both look exactly the same when we drew it. Okay, so actually, if you look at sine, where does sine start? Starts at 0 and finishes at 0 as well finishes at from 0 on the y-axis, and then it goes up and goes down and then finishes at 0 again. Where does cosine start and finish? So it starts at 1 and finishes at 1. Yeah. Alright, so that's one of the things hopefully you will recognise is that cosine starts at a max and finishes at a max, whereas a sine starts in the middle and finishes at the middle. Okay, so we've still got 360. Now, again, I think like Luke already suggested, the amplitude is, well, we go from to the max to the minimum. How far is that? So we've gone, it's from -1 to -1. So the amplitude is 2 divided by 2, which equals 1. So it's just that half the distance. So we've got 1 and 1, so that's the amplitude. Okay. So this distance here. So the amplitude of the cosine curve is the same as the amplitude of the sine curve. And Luke also correctly said the wavelength or the period of the cosine function is. So we can do it wherever we like, but we find a point where it starts. So it starts at max and we go all the way along and we find out where it gets back to where we started, and it takes 360 degrees. So our wavelength is 360 degrees. So in that sense, sine and cosine are exactly the same. They have the same amplitude and the same way. Which is why when we drew them both on the same, it just looked pretty much the same, just a little bit shifted. In fact, I can see it on Eden's paper, because you've done it with felt tips. You can see through the paper and you can see how they match quite up. Can anyone else do that with theirs? So if you look at Eden's, can you see just about? Yeah? You can see how they kind of match up. Same curve, really just shifted along a bit. Right, so those things, the amplitude and the wavelength, are two important pieces of vocabulary we need to know, and also how we find them, and also what they have to do with those three letters we looked at, A, B, and C. We looked at them yesterday. So I've got a few other ones that I've printed out for you, and we're going to look at what has changed, okay, and how can we write the function. Make sense? Yeah. So let's have a look at this next one. Okay. Now, first of all, which one is this based on? Is this based on the sine curve or the cosine curve? It's not on both. It's based on the y sine, because it's good. It starts at 0. So we're going to write down on this, we have y equals, yeah, starts at the middle bit, yeah, and then goes up, whereas a cosine starts high and comes down, yeah. We are going to base this, it's going to be a sine bx plus c, and we are going to try and figure out what the a, the b, and the c are. Yeah, that's our goal. So what I did was I drew the sine curve on the graph and then drew another one, which is what we're going to have to try and figure out. So just over to you. This is a bit tricky, so don't jump to a conclusion. Which one is the just sine x? Is it the blue one or the red one? And why? So we can say that the blue one, right, the blue one here, carry on, is the y equals sine of x, okay? And that's because we know its amplitude is 1, okay? So the amplitude there, that's the amplitude. All right? So we know that's 1. What's the amplitude of the red one there? So the amplitude of the red one is 2. So that means that the red one is the one that's been changed. We can see that already. What's not been changed? What's exactly the same for both of them? So what's that called, Sienna, again? Remember I said I'm going to ask you to use the vocabulary. What's the same in both of them?
They both then begin on 0.
They both begin on 0 and they both end at
Or 360.
360. So what have they got the same? What's it called?
The wavelength.
The wavelength. Okay? So the wavelength of both of them is 360 degrees. That hasn't changed. Okay? Have either of them been moved up or down at all? Well, they've been stretched up and down. Have they been moved up? Picked up and moved up? Remember Luke was looking at C yesterday, we moved it up or down? That hasn't happened, right? So this is where I introduce you to what A, B and C definitely do. I remember we introduced it yesterday, now we're going to talk about it in more detail. So this red curve, it's the amplitude that has changed. So the letter that has been changed, any ideas? Yeah, which letter has been changed to stretch it out like that? Who was working on a letter that made it stretch up and down like that? Yesterday. It wasn't you, because yours moved
Up and down.
up and down. What did yours do, Eden and Alistair? Yours stretched it in and out. Who stretched it up and down? A, wasn't it? You girls were doing that. A. So this is where it's the one that's quite nice. The amplitude goes with letter A. It's a bit of a coincidence, but the one we're looking at is this one. Okay? This letter here relates to the amplitude. Alright? So this is the one that's had the impact. So what would the equation of the red one be? Y equals... Any guesses? It's going to be still just sine x, but we've changed the amplitude. The amplitude has gone from 1 up to 2. What do you think A could be? 2. This would be 2 sine x. So the wavelength is how long it takes to finish its entire wave, and we've decided that's exactly the same for both of them, yeah? It's because the maximum is now at, and the minimum is at, and we look at that distance, like we were doing before, the distance between -2 and 2 is?
4.
4. So the distance is 4, and what do we do with that information? We do 4 divided by 2, and we get 2. So the amplitude is 2. Seen by just starting at the middle and going to the maximum, or starting at the middle and going to the minimum. It's how far? That make sense? Yeah. So this is what the A value does. Next one then. Again, I've left on there sine of x, and I've made a change. Which one's which? Which one is the original sine of x? Understand? Because starts at 0, but also it's one wavelength, ends at 360. So in this case, it's blue one. What's the amplitude of the blue one, by the way? 1, look. The amplitude is 1. Okay? The wavelength is 360, so this blue one again is y equals sine of x to compare to. All right. Again, we are going to consider y equals a sine bx plus c and decide which letter have we changed. What has not changed for this time? What? The amplitude for both of them is 1. So what letter has not been changed this time? The A. Good. So the A is not something we're going to consider. What has changed though? So in this case, the amplitude equals 1 in both cases. Both of them, the amplitude is 1. But what has changed?
Wavelength.
Good. The wavelength in the blue one, the wavelength of the blue one is 360 degrees. Okay? What do you think? This one, what's the wavelength of this one? Any ideas? Yeah. It's not. It's not 90. You're going the correct way. It is definitely shorter. Zero. Definitely. So remember what the wavelength is. It's how long it takes a complete wave to go before we start again. So if you remember, it's not 60. Here's the start. We're going to go up, down, through. That's the finish, right? That's a full wavelength. And then we would start another wavelength. So this would be a second wavelength. And then this would be a... So how many wavelengths are there in 360 this time?
3.
3. So the wavelength this time is going to be 120. So we're going to do 360, but divided into 3 is 120 degrees. So you can see the wavelength. Here, look. That is how long it takes one wavelength to happen. Okay. So we've changed the wavelength in this case, not the amplitude. Luke, have we shifted it up or down at all?
Not really, no.
Nope, we haven't. Look at the blue one, look at the red one, they still kind of around the same place on the page. We've just squashed it in so more wavelengths fit in the same space. So which letter, Alistair, have we impacted? Which one have we changed? It's not the A, it's the B, isn't it? This is what you and Eden were looking at yesterday. So the B has been impacted. Okay. So we are going to write the Y equals, there's no A, so I'm not going to worry about that. I'm just going to say it's sine of something X. So what's the something? Any ideas? Paused. The clue I'm going to give you is that for sine X, what's B in this case, although it's not written? What number could be in front of the X? Okay? Good, 1. There could be a 1 there, but we don't write it, right? So if sine X is sine of 1X, any ideas what you think the B could be here? I don't know. You'll get that? Hear what it says? 3. Why does he think 3? Yeah, exactly that. 3 waves happen in 360 degrees. So it's this linked to this number here. Right? So B is the number of wavelengths in 360 degrees. Okay? Another way to write that is B is equal to 360 degrees divided by the period or the wavelength. This is why it's important for you to have. So in this case, B is 360 degrees divided by 120 degrees, and we get the answer 3.
Wait, why did you close
Because the amplitude hasn't changed, so we know it wasn't A. Is it C? Has it been moved up or down? No, Luke said no to that, so we can forget about that one as well. So this case, it is B that is the impact, so we figured out what B is. Which one do you think is the sine of X? Which one, the blue or red one, is the sine of X? The blue or the red one? Blue one again?
Yeah.
Yeah, this one's it. One hopefully we're getting to recognise is y equals sine of x, the base one. Okay. If we look at the red one, okay, again, what we're going to do is we are going to try and decide if we look at our a sine bx plus c, which letter do we think has had an impact?
C.
Makes sort of sense. But let's just check, because I think you're going to say that A has also changed. Do you think A has changed? Why? What's the amplitude of the red one?
It's 2.
You think the amplitude is 2? The blue one is definitely 1, isn't it? Yeah. Get that. The amplitude of the blue one is definitely 1. We know that from our stuff before. What's the wavelength again? How many waves are there in 360 degrees? 1. So the wavelength is still 360. Is it the same for the red one? Is it not?
Yeah.
Yeah. The wavelength, there's only how many waves happen in 360 degrees? Just the one. So first of all, has B been impacted anything? Has the wavelength changed, or is it still one wavelength 360? So B is not changed this time. So we've just got to decide. We think it's C because it's shifted up. Recognise it, Luke? Shifted up.
Yep.
What do you think C would be, by the way? How far has it shifted up? It's been shifted up 1, yeah?
Yeah, so C, the amplitude would be 3.
Okay, what about C? Before we talk about amplitude, what about C? Is C, if it's been shifted up, if I look at this point, it's been shifted up 1, plus 1, that's not an amplitude, it's gone up 1, what do you think C would be then? So like this point here is also, it's gone up plus 1, everywhere look, it's plus 1, so what do you think C is going to be?
Plus 2. From
Plus 1.
the first one, it would be plus 2. What are you talking about?
This blue one has been moved up, yeah?
Yeah.
How far up?
By 1.
By 1, yeah?
Yeah.
So from 0 up to 1, or from 1 up to 2. So what do you think? I think you're agreeing with me that it's going to be sine, well we've already said B doesn't change, if B is 1. It's going to be plus 1. Yeah? The C is the thing that's changed. I think you were quite clear on this yesterday, Luke, that if it's plus 1 it moves up 1. If it was minus 1 it would have moved down 1. If it's plus 2 it's going to move up 2 and so on, yeah?
Yep.
Is it quite clear that the blue one has been moved up one square up, 1 value up? Okay, now all we've got to do is decide whether the A has changed. What do you think? I think you were already saying yes, weren't you? Anyone got a disagreement with the amplitude being 2 now? No? You all think amplitude is 2? Well, can I just take you back? Can you actually have a look at the calculation for amplitude, please?
On here.
No, on your graph. I think we did it for where we did the page on amplitude. Look at your notes. How do we actually calculate our amplitude? Divide 1 by 2. How do we figure out the number that we're going to divide by 2? If I take back the one we're looking at, here look, we talked about it here as well, the amplitude one. How do we actually work out the amplitude?
Oh,
think we also talked about it. Difference from max to min divided by 2.
Oh, yeah.
Okay? So this is the important bit. It's the difference from max to min divided by 2. So let's go down to our graph that we're currently looking at. We must find those 2 points. So where is the maximum? Well, the maximum is at,
2.
where's the minimum? It's not at -2.
Oh, wait.
It's at 0, isn't it? If you look down here, look. Here's the minimum. So actually, my amplitude is going to be from 2 to 0. So from 2 to 0 or 0 to 2. So what's that? Which equals 2. And then you divide that by 2 and get 1. So the amplitude is actually 1 still. So this is why it's important we don't just look at the number that it goes up to. So what I tend to do is, when I see a graph that's been moved up like that, I draw a line from the starting point here, look. So we've got the axis. What I do is I draw a line, a dotted line through the middle to represent where the axis would have been. And that number represents the C value, yeah? It's at +1. And now I can quite clearly see that my amplitude is from that line to there, or from that line to there. And what's that distance? 1. So has the A value changed? No. So in this case, this red curve is just sine of x plus 1. Yeah? So, just to recap very quickly before it's time to go. Like I said, I can always print it. Sine curve starts at 0, 1 wavelength in 360 degrees. The amplitude is 1. A cosine curve starts up at 1, comes down and then back up. The wavelength is still 360 degrees. The amplitude is still 1. If we start using our coefficients of A, B, and C, if I change the number A, I change the amplitude, I stretch it in the up and down direction. And however, you'll notice, look, if I now do what I did before, if I put that line through the middle, the amplitude is from that line, yeah? So it's from 0 up to 2, 0 down to -2. There we go. That's the A value. The B value is how many wavelengths happen in 360 degrees. That's a very important one. So if there are 3 wavelengths in 360 degrees, B is 3. The period is 120. And finally, if we shift it up or shift it down, what we do is we shift the centre line up or down to the number that is the +C. So the C tells me where that line is. But be very careful of where the amplitude is above and below that line. We don't just look at the maximum and go, that's the amplitude. All right? So what we're going to do next time is we're going to look at some graphs that have had A, B, C, all of them, some of them change, and see if you can figure out what A, B, and C is supposed to be. All right?